All right, so again, we have our normal regular starting function or mother function, f of x equals x squared. This time, the a value is going to change. And notice on the outside what happens. It's on the outside, and notice as it gets bigger, it's getting, well, let's try that again. As it's getting bigger, or the a value is getting bigger, we're having what's called a vertical stretch. The graph is stretching vertically. When it's less than 1, notice how the graph is wider. So it's doing a vertical shrink. It's vertical shrinking. So when it's bigger than 1 or greater than 1, it's a vertical stretch. When it's in between 0 and 1, it's a vertical shrink. Look what happens when it's negative. When it's negative, it reflects over the x-axis. So x, and as it gets bigger, or excuse me, as it gets smaller, it's getting a vertical stretch just in the negative direction, or a frowny face. And when it's a fraction, it's still a vertical shift, or excuse me, a vertical shrink, but again, it's negative. So it's going the other direction. It's reflected over the x-axis. So this is known as a vertical stretch and vertical shrink. Same thing happens when we have the absolute value. You can check again. It gets skinnier as a gets greater. It gets wider as b is, or as a is getting between 0 and 1. And when a is negative, it's reflected over the x-axis. And again, the same thing happens with our square root. So we can say that the same thing is going to happen with all of the function families. When a is greater than 1, it's a vertical stretch. When a is a fraction, or less than 1 and greater than 0, it's a vertical shrink. And when it's negative, it's reflected over the x-axis. This is known as a vertical stretch and vertical shrink. And also the negative means it's a reflection over the x-axis. Again, notice how the a is always outside of, or not with, the x value.